In the results section, you are tabulating and then graphing your data. In most circumstances, when you're applying this to a large scientific report or a poster, you really should be using Excel. You've probably gathered your data and just written it on a piece of paper or in your phone or on your computer in a fairly random way. It doesn't have to look pretty, it doesn't have to be put together in any fashion. This is a way of then looking at your data, analysing your data, and then displaying it for your audience, me and others, in an appropriate way that we can easily understand what's going on. So when you're tabulating your data, you should have already indicated what data you're using. Now, most of the time, you've gathered this data, so you're going to use all the data. But sometimes there might be outliers. So you need to have to figure out, are you going to keep or remove some data? Because even though you could tabulate that data and add it to everything else that you've got, is it necessary? Did something go wrong? So have a look at your data first before putting it into this table. And do you need to remove some, or do you need to go back and do it again and add one from that trial that didn't work, and then you have to redo that trial? Hopefully not, but that might be the case. If you don't have any outliers or ones that you think you should remove, even if they are outliers, then go onto Excel and tabulate that information. Now, don't forget, for your data table, if you've got a title up here, so they're your titles, and you might have a title down here. Up here, in your title, that is where you put your units. Units. Or units down the side. Within here, only put the data. There should be no units of measurement. No centimetres, no metres squared, nothing, only the number. And also, they should have the exact same decimal places or significant figures. I'll put sig, fig. So if your data that you're gathering is only to 2 decimal places or 1 decimal place, then everything else within that should be to 1 or 2 decimal places. Then now you have to go on and think about, well, actually before you graph it, you really should think of statistical analysis. So I'm going to do that over here. What's your stats? Can you add here to your information, can you do an average? That should be the bare minimum, an average of your trials. Because that's why you've done a trial, to make your data in the end more reliable, so you average out that data and get some averages. But then we really need to go a little bit deeper than that. So, should you do a high and a low? A range? I'll move that. Should you indicate a range here? Is that good information to give? What about the mode, the median? What's the statistical significance of these things is what you really will have to work out. And a lot of the times it comes from your hypotheses. If you're comparing and contrasting, then you want to look at the difference. So it might be high minus low, because that's a significant number that we really want, because that was in your hypotheses. Now, a really interesting one would be standard deviation. Which shows the range to which we can assume that we can rely on the data that's there. So standard deviation, I know you've done it in maths, and that's an interesting one. The very deep level, which is really only for a high level year 10 and into year 11, would be things like significance. How sure are you that this is actually the case when you're comparing two things? So that would be a t-test. Now, only think about doing a t-test, looking at whether what you see is really what's going on, and that can be done in Excel at a next level after you've done all this. If you do this to a really high order, then you can talk to me about t-test or t-test statistical analysis up online, and we'll show you how to do that in Excel. All right, last thing, graphing. Out of that information, then you should be able to go, well, what's the trend I want to see? How do I display that? And again, firstly, we just do a scatter plot. If that's an XY on Excel, okay? So a scatter plot. And then we might do a line of best fit. If you're doing categoric, just numbers and numbers. It could be a column graph, or a box and whisker plot, a histogram polygon. So there's multiple graphing required. Don't forget, in graphing, you need a title, you need X and Y axis headings and units, and it has to be an evenly spaced number line on all of those as well. If you want to use a key, make sure the key is relevant, necessary. Sometimes people put a key in because Excel does it for you, and then there's no real reason for it. So just be careful that you actually need a key for it as well. All right, good luck. Have a really good look at your stats and make sure that whatever you're doing in your graph and however you're statistically analysing the data that you gather really relates to your hypotheses.